Hi everybody. Today we're going to talk about graphing trig functions. So if you look at this picture on the right, this is what sine and cosine functions look like. They look like waves. Well, where do those waves come from? So that's what we're looking at these lessons. Where do these shapes come from? So it's just like when we did things like absolute value or parabolas or whatever. We would take the equation, we would make a table. You don't have to write this part down. Now this is a 1. And we would graph it, right? So we would go left 2, up 2, left 1, up 1. We'd plot these points, connect the points, and we would end up with the parent graph that looks like that, okay? So that is the same idea with what we're going to do with sine, cosine, and tangent. Just a little background, a little reminder, you don't have to write this part down either, but if we look at our unit circle, so this is 0 degrees, 90 degrees, or pi over 2, 180 degrees, or pi, and back to 360. We have points that look like this, and 0, -1. Okay, so if we start here by graphing y equals the sine of x, if I wanted to find the sine at 0 degrees, the sine at 0 degrees, which is also in radian 0, if I plugged in sine of 0, I would end up with, well, the sine at this function here, sine at this point is 0. If I went up to 90 degrees, the sine at that point is 1. If I went to 180 degrees, the sine at 180 degrees, or pi, is 0. Sine at 270, or 3 pi over 2, is -1. And then if we come back here, sine at 360, or 2 pi, is back to 0. Okay? So just a reminder, that's where those points come from. Well, then, of course, what we had been doing before is we do triangles. So if we wanted to find the sine of 30 degrees, again, you don't have to draw these triangles. Sine of 30 degrees is opposite over hypotenuse for sine. Well, 1 over 2 is the same as 0.5. Then if we went on to 45 degrees, so if we went on to 45-degree angle in the first quadrant, and we did opposite over hypotenuse, 1 over square root of 2. Well, 1 over square root of 2 as a decimal is really close to 0.7. Then if we did the same at 60 degrees, opposite over hypotenuse would be square root of 3 over 2. That would be very close to 0.9. We could also put those in our calculator. We could put sin of 60 in our calculator and we would get something very close to 0.9. Well, if we continue on in that faction, the sine, if we plug in sine of 120 degrees, right here, sine of 120 degrees, we would get 0.9 again. Sine of 135, we would get 0.7. So when we plug in these degree values or the radian values, this is what we'd get for y values. And then we start to get negatives. Okay. Now we're going to graph it. So we're going to graph the x values compared to the y values. And we'll do it in degrees. You could do it in radians as well. But notice the degrees, the lowest is 0 and the highest is 360. Now these are called periodic functions because this is just one period. Periodic just means that they keep repeating itself. We're just going to do one period or one cycle so we get what the general parent graph is. If I look at the y values, notice the biggest y values is 1, the lowest y values is -1. Maybe I'll mark 0.5 there as well. And now we're going to plot our points. So I'm just going to start with the ones we talked about at the beginning, and that is 0, 0, right 90, up 1, right 180, 0, right 270, down 1, and right 360, 0. Those are some nice points to remember, because when we do our transformations, we're going to look at those basic points. So notice it kind of starts in the middle, ends in the middle. The middle is the middle. And then it's going to go up from there. From the beginning, it's going to go up and down. Well, we'll kind of plot some of these other points. So if I were to do 0.5, I'm sorry, right 30 up 0.5, it would look something like this. If I were to go right 45 up to 0.7, it might look something like this. Right 60 up to 0.9, something like this. Well, if I continue on, right 120 up 0.9, right 135 up 0.7, it kind of looks like something like that. Oops, that's a little lower than that. Okay, now I'm just going to concentrate on connecting this first part, but you can see it more or less looks like a curve. Well, if I continue on in the other direction, I get a curve the other way as well. So like if I went right 10 and down 0.5, it ends up being about here. Okay, so when I plot all of these points, I end up with a curve that looks like that. Now, of course, it continues on, but one cycle starts at 0, ends at 360. One cycle or period lasts for 360 degrees, or 2 pi in radians. That's the length of one cycle. So that is the parent graph. That is just in general what a sine graph looks like. We're going to do the same thing for cosine. We're going to move a little bit quicker. I won't do all the background stuff this time. But if we go 1 equals cosine of x, again, if I start with the parent graph, don't write this part down. But at 0, remember this is 1, 0, 0, negative 1, negative 1, 0, 0, negative 1. I won't write the degrees in this time. But at 0 degrees, now the cosine is 1. This is where the cosines are. So at 0 degrees, the cosine is 1. At 90 degrees, the cosine is 0. At 180 or pi, it's negative 1. At 270 or 3 pi over 2, it is 0. And if we go back to 360, we're back to 1 again. So again, just kind of some of those values. Then if I make triangles or punch it in my calculator, if I put in cosine of 30 degrees, I would get something very close to 0.9. If I punched in a calculator or I made a triangle, cosine of 45, I would get 0.7, etc. So when we plug in these values, this is what we end up getting. Okay. And now we're going to graph those, our x's to our y's. Now I could do the radians as well, but right now I'm just going to concentrate on degrees, just get the general shape of the graph. So we understand, just like that absolute value graph looks like a V, and a quadratic y equals x squared looks like a U. What does a basic sine graph look like? Cosine graph look like? So I'll do 90, 45, 135, halfway in between is 270. Oops, 315. Okay, again, I'm going to start with kind of the basic values here. Let me just do this in pink. Pretty in pink, right? Okay, before we do that, I better go up to 1 because the highest value is 1. Lowest value is -1. Okay, so that's 1. This is 0.5. This is -0.5. This is -1. Okay, so we'll start by plotting 0, 1. Then we'll go to right 90 at 0, right 180, down 1, right 270, 0, and right 360 up to 1. Okay, and again, if we plotted some of these points in between, like we went right 30 up to 0.9, we'd end up with something like this, right 45 up to 0.7, something like that, right 60 up to 0.5, something like that. I'm going to move this up just a teeny bit. But if we connected that, what happens is we end up with kind of a curve that goes over. And if we continued on, we went to 120 down to 0.5, right 135 down to 0.7, something like this. But then we end up with this one kind of, if we connect, it goes under. If I continue on, it's going to go under and over again. So just kind of understanding that a graph comes from points on a table. The points on the table come from this equation. So that y equals cosine of x creates a set of points. Now, if I continued on, it would continue to look like that. But this is the basic parent graph, the one period of it. It starts at 0, it ends at 360. So one period of cosine lasts for 360 degrees, or if it's in radians, 2 pi radians. One last one, and that is tangent. And tangent does look a little bit different. So I won't do the unit circle again this time, but this is what happens at kind of the, where y equals 0, we end up with 0. At y equals 90, we end up at undefined. So we're just going to put a blank there. At y equals 180, we end up at 0 again. At y equals 270, it is undefined. And at y equals 360, we get to 0. Okay, so that's kind of on the x-axis, y-axis, those point values. Now, if we were to draw triangles, the tangent at 30 degrees, that is, it would be 1 over square root of 3. That ends up being about 0.6. So you can also do it in your calculator. Tan at 30 is 0.6. Tan at 45, that's that 1 over 1 is 1, or if in a calculator it'd be 1. And tan at 60 is 1.7. So if we continue kind of making triangles at each of these places and figure out what the tan value is, these are the values we get. Okay, so once again, we are going to do the x's compared to the y's. Now, again, I'm going to go 0 to 360. And I'm going to go a little bit farther this time just because I'm going to kind of show you what happens with tan. We'll put just 90 in between there, 270 in between there, 360, not halfway between 360. We'll just kind of leave that for now. We'll just, okay, good enough. We're going to go down to -90. Okay. So we'll definitely do 0 to 360. And then with the y's, notice that the lowest value that we come up with, well, there is no lowest value, but according to this, it goes down to at least 1.7, up to 1.7, and down to -1.7. So I want to go beyond 1 just to get an idea of what that is. So I'm going to go 1.5, 1. We're just going to estimate where the 1.7s are. So again, what we're trying to do is just get a general idea of what the shape of the graph is and where that graph comes from. It's just not a random curve or swish. You know, these graphs are not just made up. Graphs come from sets of points. Those sets of points come from an equation. This equation, it's the tan graph, I guess I should write that out, is y equals tan of x. So if we plot some of these points, I'll go back to pretty in pink here. If I go back to some of the main points, 0, 0. You know what? Before I do that, I think I'm gonna start with the undefined ones. These are the ones that are undefined. And where they are undefined, those are going to be asymptotes. And if you remember what asymptotes are, they are not really part of the graph. There are no points where the asymptotes are. It's undefined, but the graph approaches the asymptotes. So if we have an asymptote at 90, that's where it's undefined. Oh, that was not a very straight line. That's an asymptote, and this is an asymptote. For that matter, an asymptote occurs again at 450, and it would occur again at -90. Okay, we're just going to, from here on, we'll just concentrate on some of these basic points now. So I'm going to do it in this color. So let's go back to 0, 0 is part of it. Right 30 up 0.6 looks something like this. Right 45 up 1. And then right 60 up 1.7. Something around there. Just going to adjust this one a little bit. It's about right 30. What did we say? Right 30.6. I'm just going to lower that a teeny bit. Okay. Okay, now if we go over to the other part, right 120 up to -0.7. So that is way down here. So something like this. Let's see, right 120. So maybe about right here. And then we go right 135 and down 1. That's about here. Right 150 and down -0.6, something like this. And then 180 is at 0. Right 210 goes up to +0.6. Right 225 goes up 1. And right 240 goes up 1.7. So this is kind of the first place where we get a full graph. And I'm going to draw that over again just because I may regret this. I'll pull it over to the side. I'm going to try to make it a little smoother. Okay, something like that. Okay, and then what happens over here, we just got part of a graph. So the other part would look like this. So, you know, if we went over to 360, do you see how 360 is at 0? This is what this graph would look like. We keep repeating it. Okay. So this graph turned out a little bit flat, but it's kind of an over-under curve like that. So that's what a tangent graph looks like. Now, if you look at one cycle, notice this is one cycle right here, kind of from here to here. This is a second cycle, third cycle. Well, notice the length of one cycle goes from 90 to 270, for example. So one period is 180 degrees, or pi. So that's what's different about tangent. Is tangent, of course, it looks completely different, but the period is only half the length. So one thing to remember with tan, if you're trying to think what the basic shape is, think of where it's centered. So it was centered at 0, at 180, at 360. So it's centered at 0 and then every 180 degrees above and below that. The asymptotes are halfway in between at 90, 270, et cetera, et cetera. But if you kind of remember the basic shape of the tan graph, which looks like that, it keeps going up. It does not stop going up. Notice that if you think about the range, it's infinite going both directions. But the center of the graph is at 0, 180, and 270. The asymptotes occur halfway in between. So again, that was just the basic parent graphs in these notes of sine, cosine, and tangent.